Hello, seventh graders, and welcome to 5.2. Today, we're going to be discussing how to interpret a graph. So, we're going to be given a graph, and we have to look at it and decide what's happening in that situation, kind of put it into real life terms, or the opposite of that. They might give you like a word problem, and we have to create a graph from that. We don't have to be we probably don't have to do a whole lot with numbers, but we have to give a general sketch as to what it looks like is happening in the real event. All right. Um, we'll get started here. I'll give you a bunch of reminders, and I'd also like to share with you that it'd be a good idea to check out the tutorial videos in your MyHRW textbook, your online textbook, and you could put some of those other examples on the back of your note sheet here, your note sheet, because there's a lot of different examples. And to me, the best way to get better at interpreting graphs is just seeing more problems. So I would encourage you to do that. All right, let's look at our first example here. It says, actually, I'm going to scroll down a little bit. Give me a second. Here we go. The height of a tree increases over time, but not at a constant rate. Which graph best shows this? All right, I'm going to give you a big time hint here. And when you ever see constant rate in a graph, a constant rate is always going to be a straight line. Okay? That's a really big idea, because as time goes on, height would increase at a constant rate. So it's going to be a linear, or it's going to create a straight line pattern. And this example asks for the height of a tree, but not at a constant rate. So it's not going to be a straight line. Well, that, if you know anything about constant rates, that automatically eliminates letter A, because letter A is constant. You'll see here, as time goes on, the height of our tree in feet stays the same. The height doesn't increase. Let's say this is 10 feet, 11 feet, 12 feet. Let's say it's 13 feet. It never goes up. It stays the same as time goes on. So this tree is probably a mature tree. It isn't growing anymore. But it is a constant rate, because time is going on and it's staying the same. So that is constant. It's a straight line. This graph, however, you'll see that as time goes on, the height is increasing. And right away, it's increasing. The height is increasing really quickly, right? In a little amount of time, it's gone up a lot. But you'll start to see towards the back end here that more time is going on, but it's not really growing as much anymore. It's slowing down. Okay, but this is a curved line, and you can tell that's definitely not constant. Okay, so as the tree grows, its height increases. And then reaches its maximum height. Graph A shows the height of a tree not increasing, but remaining constant. Graph B shows the height of a tree increasing at a constant rate without reaching a maximum height. The answer is graph B. Okay. So this is going up quickly and then slowing down. Definitely not at a constant rate. Okay. Let's go to our next example. And this one is going to be one of those problems where we break it down step by step. You can see that it's awful wordy. All right, we're just going to break it down here and try to understand the problem and see what's happening. So don't get too fuzzled by the wordiness of it. Just take it one piece or one sentence at a time. It should help you. It says Jared parked his car in the supermarket parking lot and walked 40 feet into the store to the customer service counter. where he waited in line to pay his electric bill. Jared then walked 60 feet to the back of the store to get some milk and walked 50 feet to the checkout near the front to pay for it. After waiting for his turn, he walked 50 feet back to his car. Sketch a graph to show Jared's distance from his car over time. All right, this is huge because it's going to tell us on our graph what two things we need to be plotting. We're going to need to show distance and time. Use your graph to find the total distance traveled. All right, so the answer that we're looking for is the distance that he traveled. And let's think about some of the important information. Okay, so he walked to, what did he do first? He walked to the customer service counter. All right. After that, he waited in line. Jared walked to the back of the store, and then he walked to the checkout. Again, he waited in line. And finally, he went back to his car. Okay, so these are the main important ideas that we're going to need to graph. Okay, let me scroll down again. Yeah, so it wants us to make a plan here, sketch the graph, and then use the graph to find the distance, right? So the distance increases as Jared walks to the customer counter service. The distance, what when he waits in line? Well, the distance remains the same because when he's waiting, he's not going further or back from his vehicle, maybe like a step or two, but that's not something we're going to have to be that specific about when we're graphing. And then lastly, the distance blank as Jared walks to the back of the store. That's a misprint on their part. I should say back of the store. That increases as he walks to the back of the store. He's putting more miles on. Okay. Well, let's go to the next page. Sorry, I have to keep Xing out of here to get to the other pages. Okay. The distance blank as Jared walks to the checkout, well, it decreases because he's getting back closer to his car. And when he waits in line there, again, it remains the same. He's not getting closer if he's waiting in line. And then lastly, it decreases again as he gets back to his car. Okay, so now in this space here, we're going to make a graph of that. Okay, oofta, this might be a little bit tricky for me to draw a straight line. I'll do my best here, guys. So here's my y-axis, and here's my x-axis. Let's pretend that I can draw straight on my sketch pad. And a big hint that I'm going to give you is most of the time, or a lot of the time is going to be on your x-axis as time goes on, right? And then on the what was the other thing we're talking about? Well, we're talking about distance. So I'm going to write time here, and here is going to be distance. And let's look at some of our numbers. How much am I going to need to go here? Well, if you look at some of our numbers, 40 feet to the customer service, 60 to the back of the store, 50 to get to the checkout. We're dealing with some larger numbers here. If we went up by ones, that'd be a pain in the butt. So I'm going to think about maybe going by tens instead. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, so on and so forth. If you need to increase your line a little bit there. So 20, 30, 40, 50, 60, 70, 80, 90, 100. We'll see if we need to go past that at all. And time, we don't really need to label because we don't know how many seconds or minutes. It doesn't tell us that. So we'll just be vague with that. All right. So then we got to think about when he starts. What happens first? Well, Jared goes from the parking lot and walks 40 feet into the store. All right. So our first benchmark should be 40 feet. So as time goes on, we're starting at time 0. Time is going on, and we're going into the store 40 feet. Okay. So it takes him a little bit while. That's why time is moving forward. And he walks 40 feet to the customer service. After that, he stands in line. So time is still going on, but his distance isn't increasing at all. So my line should be straight, but his distance isn't changing. Then it says he walks 60 feet to the back of the store. Okay, well, I need to go 60 more feet. So 60 plus 40 would be, I should end up at 100. So time is still going on, and I get to the back of the store, which 60 more feet plus 40 would put me at 100. Okay. Then it says, and walked back 50 feet to the checkout near the front of the store. So now we need to go 50 feet back, but he's coming closer to where his car is. If his car is at distance 0, he went to the back of the store. Well, now he's coming back to the front of the store, closer to where his car is. We need to come 50 closer. So 50 minus 100 would be 50. So time's going on, I'm coming back, and I'm about at 50 there. Okay. Once again, he's going to wait in line. So time is going to go on, but he's not going to go anywhere. Okay. And lastly, after he pays, he walks back to his car. So time is going to go on, but he's walking back to his car until he gets to that 0 point, which should be back to his car. Okay. So these are the different, think about each one of these lines as a different piece of the sentence. He's walking into the store. He waits in line. He walks to the back of the store, getting further away from his car. Grabs some milk, comes to the checkout, closer to the front of the store, which is closer to his car, waits in line, time goes on, returns to his car. Okay, so the distance increase from 0 to 100 and then back to 0. 0 to 100 and back to 0. So the total distance he went 100 feet this way, and he went 100 feet this way for a total of 200 feet. Went 100 in, 100 out. Okay. So looking back, it says the graph is reasonable because it pictures someone walking away, standing still, walking away, walking back, standing in line, and lastly walking back to his car. It's reasonable because he was 100 feet away at the furthest point, and then he returned to where he started. Whew. Okay, kind of a long problem, but really breaking it down and showing you how we can kind of sketch a graph from some simple information like that. Lastly, try the check it out problem here, and then we'll be finished with our portion of the tutorial for today. All right, number 1 says the dimensions of the basketball court have changed over the years. However, the height of the basket has not changed. Which graph best shows this? Where height does not change. Well, in letter B here, you'll see that the height is increasing rapidly right away, but then it kind of evens out. In letter A, your height stays the same as time goes on. Okay, so that would be graph A. Anyone know the height of a basket in basketball? How tall a rim is? It is 10 feet. Okay. All right, that does it for what I have today. Again, a simple reminder, go to the tutorial videos in your MyHRW. That's going to be good help for you to see some more graphs, and I think it'll help you catch on. Okay. Good luck with 5.2. Let me know if you have more questions. I'll see you next time.